Hello and welcome everyone. Today's question is count smaller elements. So this question is not hard, it is a medium level question. And question description says we have to count and return an answer where answer I denotes the number of smaller elements on the right side. So starting from right side, so 4 we have 4. So on the right of 4 we don't have any number smaller than 4. For 11 we have one number, and let's suppose we are at 12. So for 12 we have six numbers on the right hand side, so we have to return an array like this. So let's build the approach. We have this array and we have to return an array of same size. So we will keep an array, and this is our answer array. We have to start from backwards. So backwards, so in this approach we will maintain an an array list or linked list. So we will add our current element on a particular position and we will return the index. So this will tell us how many numbers are smaller than this number. So suppose we have this number. So this is the only number and our suppose list is empty. Initially our list is empty. So I will add this number here. So this number is added on the 0th position in our list. So we will add a 0 here. We will put 0. This will return the index where the number is added. So now next number is 11. So 11 on the list is added after the 4. So it is index 1. So we will return the index. So it is 1. As we can see, one number there on the left hand side which is smaller. So this our list is sorted. Next number is 0. So 0 will be placed here. It will return the 0 index. So 0. Next number is 3. So 3 will place here. So it's the first index. So we will put 1 here. So it will return us the index where it is been placed on the list. Next number is 2. So 2 will be placed. So let me separate the numbers. So 0, then 3, 4 and 11. So our next number is 2. So 2 will be here. It is the first index. So I will place 1 here. Next number is also 1. So 1 is here. It is the first index. So I will put 1 here. Next is 12. 12 is the largest number. So its index is 0, 1, 2, 3, 4, 5 and 6. So its index is 6. As we can see, 6 numbers smaller than 12. So I will place 6 here. So afterwards I will return this answer array. So we can uh, update our ARR array, but this is not recommended to update the inputs. So I will make a separate answer list. So as we can see, this is our list and list size is increasing every time a number is added. So for binary search, this is where we will apply binary search. For binary search, we will have L to 0 and R to n minus 1. So why we need to get list of size? We can create a list of size initially with 0, and every time a number is added on the list, we will add our list size. So let's code this. So we have an answer array which we have to return. Next our array list and list size. So initially it is 0. So we will iterate from backwards and we have to add. So add is a function and I will add this current element, ith element, into our list array, and this is the list size. So initially I am passing ls0. So whenever a number is added, I have to add ls. I have to increment ls. So l is the size of the list. So this will return us the index. So I am placing index on the answer variable I insert ith position. At the end we have to return our answer array. So it's time for the function. So this will return us integer. So the index, this is the function, and we have to add our x value into the list. So we have L and R, L through 0 and R to n minus 1. Then we will apply binary search. So this will add our number onto a list. So let's build how we can add our number. So let's suppose we have this. Mm, so we want to add 20 here, 20 here. So we will find our mid element. So this is the mid element. So if it is equal, then we have to move to left hand side. So if the mid element is equal, then we will update our r to mid minus 1. If the number is smaller, 15, so this is our mid value. So 15 is smaller, so 15 will be here on the left hand side. So if the number is smaller or equal, then we will update our r to mid minus 1. If the number is greater 25, then we will move to right hand side. So we will update our l to mid plus 1. So that's the binary search. So if the number is equal, then move to left hand side. Number is smaller, then again move to left hand side. If the number is greater, then move right hand side. So we have this. So afterwards we have to add our x number on the l position. So the the number can be the largest number. So it will be l is equal to n. So if it is the largest number, then we have to add the number on the end. So we will add the number afterwards, and we will return our l. If it is not and l is pointing to middle of the list, then we have to insert. So we will add at a particular position. We will add the element on the lth position. So afterwards we will return our l. So that's the approach. It's a time complexity. As you can see, we have for loop, and inside this we have add function. So this add function, time complexity is log n, and its total time complexity is n log n, and space complexity is order of n. So let's submit this code. If you are watching till now, a click on the subscribe button is highly appreciated. And we have successfully submitted this code. If you have any doubts, feel free to ask in the comment section. And thank you all for watching this video.